Previously, we talked about the pavement thickness. There are requirements by the local authorities in terms of minimum thickness for different layers of pavements. And they put those requirements in the form of checklists, ensuring them to be complied with upon submissions of the engineering plan. This is an example of the pavement design. Now, this kind of requirements are meant for the roads with low traffic, that the potential growth of the traffic are relatively limited. These are applicable for typical residential and commercial development. Taking the residential development as an example, the numbers of residential units after the development shall be constant. The growth rate of the traffic and vehicles shall be quite limited. In this case, providing the minimum thickness for different layers of the road shall be sufficient. Now, in the case of the design of major roads, which are meant for medium or heavy traffic, the requirements by the local authority might not be applicable. The pavement needs to be properly designed to ensure the minimum service life of at least 10 years. And then you're going to expect there shall be annual growth rate for major roads. Now, the pavement needs to be properly designed. The pavement design pass at the current stage might not necessarily pass at the end of the design period of 10 years. Therefore, the design of the pavement shall be on basis of the design period of at least 10 years. The next question here is, how are we going to design for the pavements of major roads meant for medium and heavy traffic with expected annual growth, so that the pavement can service at least 10 years of design period? You may refer to the Arahan Teknik JKR, the manual on the pavement design. This document can easily be found in the internet. Some brief introductions regarding the Arahan Teknik, where the structural design here is based on ASHO, American Associations of State Highway Officials, based on their road test result. However, the design method is developed using the multi-layer elastic theories through the use of chevron and layer computer program. Now, the applications of the manual is for the design of the flexible pavements for roads under the jurisdictions of JKR. We are talking about the flexible pavement with bitumen as the binding material. It is used for the design of major roads. The minor roads, giving access to the residential areas and etc., are not within the coverage of the pavement design recommended in this manual. Now, let us have a look in terms of the pavement structures. This is common. There are subgrade, subbase, base, and surface course. The surface course can be divided into two: the binder course and the wearing course. Sometimes there may be 2 layers or more for the binder course here. Under such circumstances, the lowest layer shall be considered as the binder course, while the others shall be considered as the intermediate course. About their function, the subgrade is the lowest layer of the pavement. It is basically the soil layer where the pavement should be laid on top of it. The soil can be natural or can be imported. The functions of the subgrade is to support the load transmitted from the overlaying layers. Normally, the subgrade should be well compacted in order to increase its bearing capacity. By fundamental, the strength and capacity of the pavement is very much governed by the subgrade. And the functions of the other layers are mainly to disperse the load into smaller stress up to an extent that the bearing capacity of the subgrade is greater than the stress acting onto the subgrade. As long as the subgrade has larger bearing capacity than the stress acting onto its surface, theoretically, the pavement shall be in good conditions. Above the subgrade, that will be the subbase course. Its function is to disperse the load from the base course before transmitting to the subgrade. This slide shows the basic principles of the pavements. By having the traffic on top of the pavement, the weight of the vehicles shall impose load onto the pavement through the wheels of the vehicles. And this kind of loads are normally point load, where there are going to be high concentrations of the stress at certain regions, and the magnitude of stress will reduce over a bigger areas. This high level of stress cannot be directly taken by the subgrade due to the low bearing capacity of the soil layers. That's why we need a pavement of certain required thickness in order to disperse the stress so that a bigger areas of the subgrade can be engaged in resisting the load. When you compare the stress at the road surface against the stress acting on the subgrade, after the dispersions of stress by the road layers, the magnitude of stress has reduced, whereas the magnitude of the load shall theoretically be the same, because the same magnitude of the load, the total area below the curve for the road surface and the subgrade should be the same. When a larger area of the subgrade is engaged in resisting the load, the magnitude of the stress can be reduced. You will need to properly design the pavement to have sufficient thickness until to a stage that the peak stress here is not greater than the bearing capacity of the subgrade. That's the functions of the pavement layers. The base course, it will be above the subbase. Its functions is to support the upper layer and disperse the traffic loads. And then the traffic load is further dispersed by the subbase so that the stress when reached to the subgrade here are less than the bearing capacity of the subgrade. The surface course here are all the layers above the base course. The wearing course, intermediate course, and binder course are considered as the surface course. These layers form an impermeable and flexible lining of high elastic modulus. The surface course needs to be impermeable to prevent the penetrations of the water, undermining the capacity of the subgrade later. We do not like water to disturb the subgrade underneath the pavement. The binder course will have bitumen as the binder, and its function is to support and disperse the traffic load. At the same time, it needs to have the resistance to shear loads. The shear resistance of the binder course allows the distributions of the stress over a large areas of surface. And then the utmost layer, it will be the wearing course. This will be the layer having the direct contact with the traffic, and therefore it is designed to be abrasions and skid resistance. Resistance to abrasions ensure the structural stability of the pavement, Skid resistance is for the safety of the traffic on the pavements. Next, let us talk about the thickness design for the flexible pavement as given in the Arahan technique. The thickness design for the pavement shall be based on the design CBR, which is the California bearing ratio of the subgrade, and the total numbers of 8.6 ton standard Asia applications for a specific design period. The design CBR of the subgrade and the total equivalent standard Asia are the main factors in the structural design of the pavement. And you will need a design chart, which is the thickness design monograph, to do the design. We shall discuss the design process in the following videos.